Welcome to this lecture on higher order derivative test, an application of Taylor's theorem by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
So today we are going to continue with another application of Taylor's theorem, which is finding relative extrema of a function and also discussing the nature of function, whether it is convex or not. Okay. So in this line, we are first going to do higher order derivative test. So to determine whether a point is point of relative extrema or not, we already did a test, which is first derivative test, right? We have already done first derivative test to determine whether a point is relative extrema or not, right? इसमें क्या होता है first derivative test में? If there is some point C and if we check the sign of f dash, right? If it is from positive to negative, then that is point of maxima, and negative to positive, that is point of minima. Okay, so this test we can easily determine whether a given point is point of relative extrema or not. But there is another test which is called higher order derivative test. So a similar test you have done in as second derivative test, right? You are already done second derivative test. What was that? In your 12th standard you have done the second derivative test. What is that? Yes.
F double dash x greater than 0 than relative maximum.
Yes.
Sorry, minima.
If f double dash x is greater than 0, then f has relative minima at that point, right? And agar f double dash is negative, then relative maxima, right? So similar to that, this is our higher derivative test. In fact, it is a generalization of second derivative test. So let me just give you the statement of this higher order derivative test. So this is the theorem. So what it says that if I is an interval and x naught is any interior point of I, and for n greater than or equal to 2, suppose the derivatives f dash, f double dash, fn exist. So all these derivatives exist and are continuous in a neighborhood of x naught. So in some neighborhood of x naught, so this thing is happening that f dash, f double dash, fn all exist and are continuous in a neighborhood of x naught, and that f dash x naught equal to this is 0. Okay, f dash x naught to fn minus 1 x naught all are 0, but fn x naught is non-zero. Okay. Then we have three conclusions. First, if n is even and fn x naught is positive, then f has relative minimum at x naught. So it is, if you see, agar n equal to 2 and f2 x naught is positive, then wo same second derivative test, right? If n is even and fn x naught is less than 0, then f has relative maximum at x naught. And if n is odd, if this term is 0 for odd number, non-zero for odd number, then f will neither have relative minima or nor it will have relative maximum at x naught. ठीक है? So अगर किसी point पे relative maxima या relative minima है, if any point is point of relative extrema, then for odd n, fn x naught should be equal to 0. ठीक है? Okay.
Yes, sir.
Okay. So let us try to prove it, write its proof. It's very simple. Okay, we will use Taylor's theorem again for here. So first we will use the fact that fn x naught is not equal to 0. So what does this imply? Since fn x naught is not equal to 0 and fn is continuous in neighborhood of x naught, what does this imply? There exists a delta neighborhood v delta of x naught such that what will happen? Fn x is not equal to 0. In fact, it will have the same sign. Fn x naught will have the same sign as fx naught, right? And fn x naught will have the same sign on for all x belonging to v delta of x naught, right? Do you remember this result? Same result if fc is non-zero and f is continuous at c. Okay, so non-zero की जगह greater than है. If fc is greater than 0 and f is continuous at c, then fx is greater than 0 for all x belonging to v delta of c, right? This result. And similarly, fc less than 0 and f is continuous at c, then your fx is less than 0 for all x belonging to v delta of c, right? Agar if the function takes positive value at that point and function is continuous at that point, then the function will be positive in the neighborhood of that point, right? Remember this result? Yes, we have used this result several times. Yes.
Yes, sir.
Okay. So we have used this result that if let us just keep this result with us. Okay, so we have used this result. Okay. Now, so we have seen that fnx and fnx naught will have the same sign over the interval v delta of x naught. Okay. What will happen by Taylor's theorem? At x naught, there exists c lying between for each x belonging to x belonging to v delta of x naught, there exists cx lying between x and x naught such that, yes, what will happen? Fx will be equal to fx naught plus f dash x naught x minus x naught plus f double dash x naught by 2 factorial x minus x naught square plus so on plus fn. So अभी क्योंकि हमें fn तक दिया हुआ है डिफरेंशिएबल, सो हम n-1 तक वो लेंगे पॉलिनोमियल अपना, ठीक है? fn x naught by n-1 factorial x minus x naught to the power n-1 plus और रिमाइंडर आफ्टर n टर्म्स लेंगे, ठीक है? n+1 की जगह वी आर यूजिंग n. Is it fine, everyone? So this is your basically Rn minus 1x and this one is your Pn minus 1x. ठीक है? Is it fine? Yes. Is it fine, everyone?
Yes.
Okay. Now what will be our fx? So then अब देखो fx f dash x naught this is 0, f double dash x naught this is 0, fn minus 1 x naught this is 0 because these are given to be 0, right? fn dash x naught fn minus 1 x naught are all 0. So हमारे पास क्या बचेगा? This will be equal to fx naught plus fn c x minus x naught to the power n by n factorial. F dash x naught is equal to so on fn minus 1 x naught equal to 0. So we have used this result. Okay. So we have shown this for all x belonging to v delta of x naught. This is true for all x belonging to v delta of x naught. अब हमें अगर x naught को पॉइंट ऑफ एक्सट्रीमा शो करना है तो क्या होगा? हमें क्या शो करना होगा? Now case 1, if n is even and fn x naught is positive, ठीक है? So ये केस दे रहे हैं हम. Then what will happen? You have to show that f is relative minimum at x naught. relative minimum की definition क्या होती है? कोई पॉइंट relative minimum कब होगा? Yes, what is the definition of relative minimum?
f double dash x will be less than 0.
नहीं, definition, basic definition. F is relative minimum at C if fx is less than fc for there exists some delta, right? There exists some delta neighborhood in which for all x belonging to this, right? In some neighborhood of C, fc is the fc is the it should be minimum value. Okay, we are talking about relative minimum. ठीक है, so हमें ये show करना होगा basically. We have to show that fx is greater than equal to fx naught for all x belonging to v delta of x naught. So how you will get that? Okay, mark it as star and make it double star. This one is double star. ठीक है, नीचे वाले डबल स्टार है तुम्हारा और ऊपर वाला स्टार है. स्टार क्या कह रहे हैं कि fnx naught fnx and fnx naught will have the same sign over the interval v delta x naught, and this one is saying that fx will be equal to fx naught plus fncx, ठीक है, plus this. Okay, now so then from what will happen from star? fnx is greater than 0 for all x belonging to v delta of x naught, right? Okay, so from star we have this fnx naught is fnx is greater than 0 for all x belonging to this neighborhood. Now as x belongs to v delta of x naught, where will cx belong? Cx belongs to v delta of x naught. Why is it so? Since cx lies between x and x naught. Okay, is it fine? So cx will also belong to v delta of x naught. So this implies fn cx is greater than 0, right? Then from double star what will happen? fn cx by n factorial x minus x naught to the power n is greater than 0. Why is it so? क्योंकि देखो ये पॉजिटिव है and n is even, so this term is also positive, right? So overall it is positive since n is even, right? Sorry, not from double star. So this implies this, okay? And then from double star we conclude that fx is greater than equal to fx naught for all x belonging to v delta neighborhood of x naught, and this implies f has relative minima at x naught. Fine? Yes, is it clear everyone? Yes, is this clear everyone? This part, if n is even, then your fnx naught is positive, but हमने यहाँ पे स्टार में कहा हुआ है कि fnx and fnx naught will have the same sign over the interval v delta of x naught, मतलब कि fn जो है इसमें अगर fnx naught is positive then fn will be positive in this interval, and if fn is negative then fnx naught will be negative, then fn will be negative in this interval. So अब यहाँ पे we have taken the case when fnx naught is positive, so in that case fn is positive in this interval, and since your x belongs to v delta of x naught, so cx belongs to v delta of x naught, and consequently your fn cx is positive. And fn cx positive means this term is positive, this is your rn minus 1x, right? And that is positive means from here if you see double star, If you see double star, fx is fx naught plus this. So if this is positive, that means fx is greater than equal to this, right? Is it fine, everyone?
Yes, sir.
And case 2 में क्या होगा? n is odd. Case 2, n is even and fn x naught is less than 0. So it will be on the similar lines. So again from star ये negative हो जाएगा तुम्हारा, and then this will be negative, and again this will be negative क्योंकि ये तो positive है, n being even. So again from double star we conclude that fx is less than equal to fx naught for all x belonging to V delta of x naught. So this implies f has relative maxima at x naught. ठीक है? So अगर fn is negative, then f has relative maxima at x naught, provided n is even. Now case third, when n is odd. So basically we have to show that fx is less than fx naught in some at some points, or fx is greater than fx naught at some points in this neighborhood. So वो कैसे करोगे proof? So यहीं से आ जाएगा क्योंकि fn x naught and fn x will have the same sign. So either it is positive or it is negative. ठीक है? So अगर वो positive और negative है तो इसका जो sign होगा, this thing is either positive or negative, but ये जो अपने आप में sign change कर रहा है क्योंकि if you have x greater than x naught, क्योंकि n odd है तो x greater than x naught पे ये positive हो जाएगा, तो इसके sign पे depend करेगा. अगर x greater less than x naught है तो ये negative हो जाएगा. So x then x minus x naught to the power n is negative if x belongs to V delta of x naught and x is less than x naught, and x minus x naught to the power n is positive if x belongs to V delta of x naught and x is greater than x naught. So this implies fn cx by n factorial x minus x naught to the power n will have opposite signs as we move from left of x naught to right of x naught. ठीक है? या तो पॉजिटिव होगा या नेगेटिव होगा, लेकिन ऑपोजिट साइंस होंगे, राइट? एंड consequently we will have इसको चलो प्रॉपर्ली लिखिए, then you will understand. ठीक है? Now sub case 1, fn x naught is positive. ठीक है? Then fn x is fn cx is positive. ठीक है? Yes, fn x naught is positive, then fn cx is positive, and this implies fn cx by n factorial x minus x naught to the power n is positive if x is less than, sorry, x is greater than x naught, right? Yes, x is greater than x naught, and negative if x is less than x naught. Consequently, so this implies fx is greater than fx naught if x is greater than x naught, and fx is less than fx naught if x is less than x0. So this implies f is neither f has neither relative maxima nor relative minima at x0. Sub case 2, सब केस 2 में क्या हो जाएगा? fn x0 is negative can be proved on the lines similar to sub case 1. It can be shown that यही शो कर देंगे ना. ठीक है, बस our signs will change. This will become negative, this will become positive. So f is neither relative maxima nor relative minima at x0. Is it fine, everyone? So this completes your proof. So we have shown that if n is even and if x0 is positive, then f has relative minimum at x0. If n is even and if x0 is negative, then f has relative maximum at x0. And if n is odd, then f has neither relative minimum nor relative maximum at x0. So is it fine, everyone? किसी कोई doubt इस theorem में?
No, sir.
Okay. So इससे ये देखो, इससे ये पता चलता है कि अगर रिलेटिव मैक्सिमा और रिलेटिव मिनिमा है किसी पॉइंट पे, तो ऑड वाले पे तो हमेशा ही जीरो होगा हमारा. ठीक है, इवन वाले पे नॉन जीरो होगा, और इवन वाले पे अगर साइन चेंज कर रहा है तो अगर पॉजिटिव है, जैसे सेकंड डेरिवेटिव टेस्ट में होता है, अगर पॉजिटिव है तो रिलेटिव मिनिमम, नेगेटिव है तो रिलेटिव मैक्सिमम. सिमिलरली कोई भी हो, खाली सेकंड नहीं, कोई भी फोर्थ डेरिवेटिव भी हो सकता है, सिक्स्थ डेरिवेटिव भी हो सकता है, एट्थ डेरिवेटिव भी हो सकता है. तो जो भी पहला नॉन जीरो आ रहा है, फर्स्ट नॉन जीरो आ रहा है, ठीक है, द फर्स्ट नॉन जीरो डेरिवेटिव दैट शुड बी, अगर रिलेटिव एक्सट्रीमा है तो दैट शुड बी इवन. ठीक है, दैट नंबर शुड बी इवन. और साथ में अगर वो पॉजिटिव है तो मिनिमा, अगर नेगेटिव है तो मैक्सिमम. ठीक है, वी नीड ऑल द सेम, सब कुछ सेम ही होना चाहिए, बस वी नीड दिस. What it says is that if f has relative extrema, okay, if f has relative extrema at x0, then n is even. ठीक है, is it fine, everyone? तो ऑड पे कभी भी ऑड पे नॉन जीरो नहीं होगा. तुम्हारा जो भी पहला नॉन जीरो नेगेटिव वो लीस्ट वो नॉन जीरो पॉइंट है, तो उस पे वो n जो है वो इवन ही होगा, ऑड नहीं हो सकता. ठीक है, इज इट फाइन? ठीक है, follows immediately from last year. बस उसी की रीस्टेटमेंट है, उसी को हमने बस एक वो कंक्लूजन निकाला है. क्योंकि हमने यहाँ पे क्या कहा है कि ऑड वाले पे तो होता ही नहीं ना रिलेटिव मैक्सिमा और रिलेटिव मिनिमा. सो अगर n पे रिलेटिव मैक्सिमा रिलेटिव एक्सट्रीमा है तो वो इवन ही होगा नंबर. बस इतना ये इसलिए लिखवा दिया कि ये ध्यान रहे कि इवन पे ही आता है, ऑड पे नहीं आता है, ये ध्यान रखना है. ठीक है, इज इट फाइन? और ऑड पे भी अगर पॉजिटिव है तो रिलेटिव मिनिमा, और अगर नेगेटिव है तो रिलेटिव मैक्सिमा. ठीक है, let x naught be an interior point of x naught, oh, I of interval I, let f from I to R be function such that first such that f dash and f double dash exist and are continuous and are continuous in neighborhood of x naught. Also f dash x naught is equal to 0, then and f double dash x naught is non-zero, and f double dash x naught is non-zero. Then what will happen? First, f double dash x naught greater than 0 implies f has relative minima at x naught, and second, f double dash x naught less than 0 implies f has relative maxima at x naught. Okay, is it fine everyone? Is it fine? इसका भी proof जो है follows from higher order derivative test. ठीक है, उसी का ही सेम, बस इसी को रीराइट करा है, एक पर्टिकुलर केस दे दिया उसका when n is equal to 2. ठीक है, is it fine everyone? Any questions you want to ask?
No, sir.
Okay, fine. So then I'm ending this class. Bye everyone. Have a good day.
Thank you, sir.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.